Hey, it's Mr. Redstone, and in this video we're going to be talking about the domain and range of relations. So I'm going to do 4 examples, all different types, and hopefully by the end of this video you'll be a little bit more confident in this topic. So first, what does domain mean? It means the inputs, or the set of x values for a given relationship, and the range is the corresponding outputs, or the y values. This first example that you see is what we call a discrete function. It only exists for specific values of x, or specific inputs. To show what those inputs are, what I'm going to do is draw some vertical lines. See, this first point hits the x-axis there, second at -2, third at 0, and fourth at 4. So to write the domain, all we have to do is specify those x values. -4, -2, 0, and 4. If you were to choose any other x value, like x equals 2 for instance, it doesn't matter if you went all the way up or all the way down, there's no resulting output. Since there's no output, it's not a valid input, we don't include it in our domain. The range will be the corresponding values of y. So for that first coordinate on the far left, the corresponding value of y is -1. For the second point, your y value is 4. Your third point, your y value is 1. And your fourth point, the y value is 0. So based on those purple inputs, the resulting outputs are shown in red, and that is your range. For the next example, I've got a horizontal line that goes forever to the left and forever to the right. Now, if you were to choose any input, any value of x, and follow it up to see where it meets the graph, you would see that it always meets the graph. There always seems to be an output, no matter what input you choose. So since any input gives you a resulting output, we say that the domain is all real numbers. And the way we write that is with this script E. It means it's an element of the set of real numbers. Now your range, you've got to look carefully at this horizontal line. It doesn't matter what input you pick, you're always going to get the same output of 3. So this next coordinate, -2, your output is 3. 0, your output is 3. So your only output that you ever get is 3. But be sure to specify that y is 3. Otherwise, your teacher might think that you're talking about x. Next up, I've got what we call a piecewise continuous linear function. That's a mouthful. Now for the domain here, I'm going to give you a visual aid and draw these 2 blue vertical lines. If I were to go to the, getting low. If I were to go to the left of that left line, there's nothing there. It's not valid inputs. Just like if I went to the right of the line on the right, there's nothing there. What I need to show is that the inputs only exists in this window. So we're going to be doing that with a compound inequality. We just want to show that the x values lie between -4 and 3. So compound inequalities can give students some difficulty. So what we're going to do is break it up into 2 parts. We say that the x values are greater than or equal to -4, meaning -4 in that way. But they're also less than or equal to 3, meaning 3 and to the left. Well, that overlapping region, that's what we've indicated in blue. I'm going to do the same thing now for the range. As you can see on this graph, the highest y value we'll ever get is 4. The lowest value we can ever have is -3. So we have to show that the y values are always in that window. And we do that again with a compound inequality. And I'm sorry that my head is cutting off the words domain and range. So we're going to show that the y values are always greater than or equal to -3. That's what the first inequality says. The second piece of it says that the y values are always less than or equal to 4. And that's it. Last example. You can see I have a piece of a linear function. I've got a solid dot and I've got an open circle. And yes, they mean different things. So just like before, for the domain, I'm going to show the lowest value of x and the highest value of x. And the domain exists in between those blue lines. So your domain is going to be from -7 all the way up to 7. But here's where that open and closed circle come into it. An open circle means that it'll never equal 7. The filled in circle means it can equal -7. So the way we show this domain is with, again, another compound inequality. The x values can equal or be greater than -7, but they're going to have to be less than 7. It'll never equal 7. It'll never be greater than 7. For the range, we'll do the exact same thing I did before. I'm going to draw two horizontal lines to show the highest value of y and the lowest value of y. And again, those open and closed circles come into it. On the low side, it can equal -3. But on the high side, it will never equal 8. So the range will exist between -3 and 8. It can equal -3, but it won't equal 8. And here's how we'll write it. -3 is less than or equal to y, which is less than 8. So that's it for this video. Thank you for watching. And if you need more examples, I assure you there's plenty of stuff out there. See you next time.